We ready? Okay. Hi, I'm Borislav, and if you want, you can follow the slides over here on your phones or tablets. That's is.gd/html5 GUI, all lowercase. I'm mostly a C++ programmer, though I do a lot of other languages too. I'm mostly a game programmer. The vast majority of my career has been in games. But recently I made a career change of sorts, and I'm now working on medical software. I do a lot of open source. You can find my repos over here if you want. And this talk is about using HTML5 as a GUI framework for C++ applications. I'll cover a lot of ground and 3 different approaches, many variants of those approaches. And keep in mind, though, that the talk is much more inspirational than educational. I mean to motivate you to perhaps consider using some of these approaches, experiment with them, and that's why I've provided some demos so you can start experimenting right away. So, you want to make a GUI. A typical user interface works like this. You have your application, you have your user interface, and they communicate. The application sends data to the user interface to present, and the user interface sends commands back to the application which change the data. You could want a simple GUI, so a couple of widgets, nothing too fancy. And in this case, your program might well look something like this. You have your executable, which runs the application, and the same executable also runs the GUI, the user interface, and they communicate with some functions, say get this, set that, stuff like this. And in such a case, my advice is to just use whatever you're comfortable with. Whatever you know, whatever you like, it doesn't matter that much, actually. My personal recommendations in this category for simple GUI are libui and DRM GUI. They're great. Check them out if you want. So, let's say you want a complex GUI. Let's say you want some kind of diagrams, something fancy widgets, animations, all the jazz. You want MVC, where the application is your model, the user interface is your view, and there's some kind of a controller which facilitates the communication. In a typical C++ program, that model view controller might be realized like this. You have the executable for the application, then the same executable runs the user interface, but they're in 2 separate subsystems or 2 separate threads, and they communicate with messages or signals or whatever you want. And for many people, the answer to the problem of having a complex user interface is Qt. And it's a decent answer. Qt is really powerful and definitely can get the job done. But is there something else? And I'm here to talk about that something else. And this thing are browsers. This, of course, Netscape, the mother of all modern browsers. And its children sure have come a long way, haven't they? Modern browsers are amongst the most sophisticated pieces of software ever produced. They're highly optimized in terms of performance and power consumption, and they are powerful. For example, this is a browser. See, I can press F11 here. You can see this is a browser. Perhaps some of you have opened the link. You're seeing the same slides in your browsers, on your phones and tablets. You could have simple widgets in the browser. They're all clickable here in my presentation. I can add some text. I can click on the checkboxes. I can click the button. It does nothing, of course, but it's still there. This is an SVG image. This is an animated GIF, which illustrates typical C++ development. This is a YouTube video, and of course, you know, the browser can open these. This is real-time 3D graphics from ShaderToy running in the browser. And you know what? These last 5 slides with the fancy stuff, they took me about 10 minutes to make. I just looked for what I wanted to embed, and I embedded it. That's how easy it is. The thing is that the browser is an immensely powerful presentation platform. It's a user interface platform. It's our user interface to the internet. And the internet has everything, so that means that the browser should be able to present everything. So browsers are sophisticated, optimized, powerful, but most of all, they're ubiquitous. Browsers are everywhere. For example, this is a fridge, and on this fridge you can open Facebook or Twitter. And there's something else. These are screenshots from the Stack Overflow survey of this year between, I think, 90,000 developers. And notice here, those are how developers self-categorize themselves in terms of what their type is, I guess. Those near the top, those 2, most of them write code for the browser. These here, the languages they use, These languages are mainly used for the browser. Number 2 on the right side, this is entirely the browser. And that's what, like, carry the 4, like 200% of developers actually write code for the browser, right? Anyway, seriously though, you're probably familiar with how hard it is to find decent C++ developers. And also, if you have decent C++ developers, you probably wouldn't want them to I don't know, in a way, waste their time doing GUI. You would want them to actually write the application, right? That's what they're for. And given that the browser is so ubiquitous and the number of browser developers is so huge, it's much easier to find decent browser developers. So browsers are really powerful. Browser developers are everywhere. Can we make use of that as C++ application writers? And before I continue, I should just say what HTML5 is, and I'll be very brief because most of you are probably familiar with the concept. So HTML5 in 1 minute in a single slide. First of all, HTML5 is not a single thing. It's a stack of 4 languages. You have the declarative languages, which are HTML, which defines the elements of the page, and CSS, which describes the style of the elements or the appearance of the elements on the page. And both of those, they define the DOM, Document Object Model. The DOM is basically the structure of our page. And you have imperative languages, which change the DOM. Then they modify it. And those languages are JavaScript and WebAssembly. And that's it. That's what every single web page out there is, including this one. See, I can press Ctrl-U, and you can see the source of the page. I won't zoom in, you basically see what I mean. This is a simple web page. It's all HTML, CSS, JavaScript. In this case, no WebAssembly. So what is HTML5 development then? Is it writing HTML, CSS, and JavaScript? Well, in a way, yeah, but it's a bit more than that. Remember this thing, the most popular languages out there? See the third one, TypeScript? I didn't mention TypeScript before. The thing is that this huge community of young hipsters that write JavaScript, well, they have developed some neat stuff. For example, they developed a lot of languages. CSS, I did mention CSS, it's a terrible language. Nobody wants to write CSS. And hence, hardly anyone does. Lots of people use less or Sass or many other languages which are then compiled to CSS. JavaScript, it's a decent language, but many people don't want to write JavaScript. They've created many languages which compile to JavaScript. TypeScript is among the more popular ones, CoffeeScript too, and there are many others. In fact, C++ can be compiled to a subset of JavaScript called asm.js. And there are many languages and templating engines which generate HTML, and compiling to WebAssembly is all the rage these days. Every language does it. C++ does it. You know, there was a keynote about using C++ to generate WebAssembly. And those young hipsters have developed some fancy workflows too. For example, there's Node.js. Now, to many of you, Node.js may be a server solution in a way, but in fact, Node.js is the de facto JavaScript interpreter for desktop. And it's used for many things. And in fact, practically every front-end developer, the one that write code for the browser, they use Node.js in some way. Node.js runs a lot of package managers like npm, yarn, and webpack. And it supports a marvelous workflow of all of those have their own kind of build servers. But for example, npm start is pretty popular. Typically, a front-end developer will just run npm start, and this will launch a process, which is the build server, which watches the file system, compiles Sass to CSS, compiles TypeScript to JavaScript, launches the web browser, refreshes it if it needs to, and it's great. The experience is awesome. It's great, isn't it? They have lots of debugging helpers, debugging tools. If you know, I can press F12 here. This will open me DevTools for Chrome. Other browsers have their own variants. This allows me to debug, to break within the web page, to change the code as it's running, to change the DOM. For example, if I click here and go to inspect, see this page here. Oh, done. This is pretty neat, isn't it? They have developed some powerful frameworks, and I'm sure you've all heard of React, Vue, or Angular, and there are many others. So HTML5 development is modern. It's very effective, and allows the developers to be very productive. So it's something pretty neat. Okay, enough of me selling you the concept of HTML5. The HTML5 corporation paid me enough. So approach one, a local HTTP server. Basically, this means to start an HTTP server on your computer and then open a browser on the same computer to localhost and some port. But this is not just any HTTP server. This is our application. And much like we had the application communicate with the GUI with commands and messages, this works the same way. But instead of messages or signals, the communication is done via HTTP. Now, this has been done since the early 90s. And those early attempts were multi-page applications. Basically, a multi-page application is where you click a hyperlink, it requests a page from the server generates it, sends it back, you open that page. That's it. This is a simple demo. It's not in C++, it's in Python, but I'm sure you'll get the picture. So I can just start a Python web server. I can open, I started at 8080, right? And you see, the browser requested the web page, the server generated the contents of the directory. So this is a simple file system browser running in Python. I can click on the directories and open, I can click back. It's pretty simple. Every click generates a new page. That's basically it. In this case, the server is serving dynamic content. And this is not great, because this means that our application will need to generate HTML. There's some GUI logic, the HTML generation logic is situated in our application. And that's not what we want. That's not MVC. That's not cool. In the language of our diagram, this looks something like this. It even looks broken. You have your executable and the same executable. It generates some HTML. It communicates to the browser. It's not great. Not great, not terrible. And the key part here is that multi-page applications are typically not interactive. I mean, they do interact with the server, but there is no way for the server to say something to the application on its own time. And that makes them generally a bad idea. Now, they can qualify in a simple GUI, as a simple GUI. And if it's easy for you, if that's what you want, if that's what you know how to do, then sure. And in fact, to this day, I think that this is the PHP programmer's GUI of choice, multi-page applications. Anyway, we're going to do something more modern, single-page applications. In a single-page application, JavaScript actually is used to modify the DOM and implement the GUI logic. And there's not a new URL on every click. You stay on the same page, hence the single-page name. And this started in 2004 when AJAX came to be. AJAX stands for Asynchronous JavaScript XHR, and XHR stands for XML HTTP request. And if this name sounds a bit Microsofty to you, then you're right. It was created by Microsoft. Notice the XML there? Well, luckily, you don't have to use XML with an XML HTTP request. And if this sounds a bit Microsofty to you, then yeah, again, you're right. Basically, any text or binary works with this request. The thing is that this doesn't sound very interactive now, does it? You always need to make requests and then wait for responses. So in order for the server to tell us something, we need to ask it first. Now, luckily, web developers devised a hack around this, the interactivity hack. So this is basically how it works. We request some resource from the server, and this is not the real resource. This is client-ready, some kind of a message. When we receive the response, we dispatch it to the application, to the GUI, for example. So it needs to be rendered and whatever else. And then we call the same function again, opening the same XHR to the server. So that basically maintains a continuous connection between the browser and the server. Hacky, in a way, isn't it? Where is this XML HTTP request? You say, well, it's hidden behind those fancy functions. Those basically expand to this. This is the exact same thing. You create the XHR, you get the resource, you dispatch your response, call the same function again. And if any one of you happens to write AJAX these days, use fetch, don't use this. This is really old school. But I don't have an AJAX demo because we're not going to do AJAX today. We are moving to HTML5, and HTML5 is more modern and has another feature, WebSockets. WebSockets are cool and they take the XHR interactivity hack to the next level, basically. It's a much simpler and cleaner way to communicate with the server. And it's more powerful, too, as we'll see in a while. So this is how a WebSocket works. You open a WebSocket connection to some URL, you fill some callbacks, and then you can send message to the server and receive the responses in the onMessage function. And this, again, maintains a continuous connection between the server and the client, and every party from both sides of the connection can communicate in their own time whenever they want. So our application architecture with a local HTTP server might look something like this. We have a server, which is our application. We have a browser, which is the user interface, and they communicate via WebSocket or XHR. But this is probably not that cool, because remember the marvelous workflow that modern web developers use, npm start, the build server. There is no way for us to start it here, is there? Because if the server is our C++ application, the first thing that the browser is going to request when it opens the URL is HTML5 content. How are we going to provide it? We could re-implement npm in the marvelous workflow, but no, this is not something that we want to do. We could have our HTML5 developers give up their marvelous workflow, but then this is something that we want to do even less, because they're young, they have their ways. Anyway, what we could do, though, is create a node module. Now, Node.js allows us to create, because it's a JavaScript engine for the desktop, it allows us to have desktop functionality. For example, opening shared libraries. We could create a Node module, which is a shared library. We could have it communicate with Node, and then Node will take care of all communication and the npm fancy stuff. And it will serve as a proxy between our application and the user interface, the browser. This is what we did in a company I used to work for before. And it made sense for us, because we had a lot of application logic, not only in C++, but also in JavaScript. So actually, Node was useful for us for more than just a proxy. But again, this could work if you're willing to communicate to JavaScript for every single thing. This is fine. It works. But I mentioned that WebSockets are more powerful. And what makes them more powerful is this. This URL here. This doesn't need to be the same URL that we've opened with the browser. Instead, we could do this. And this is, in my opinion, a much cleaner interface. We have the server, which is Node, or I don't know, Nginx or Apache, whatever you want, which provides the HTML5 content and all kinds of other HTTP requests. And we have our C++ application, which only runs WebSocket and communicates with the browser via WebSocket. It's a different application. And it's much cleaner, much simpler. It doesn't have to deal with all the cruft of the HTTP server beside it. So how do we add WebSockets to our C++ application? Well, there are many options, but luckily it's 2019, and there are many open source options, and we can do whatever we want. And this is CppCon, so I'm going to use BoostBeast. BoostBeast is by Vinny Falco. He's from the C++ Alliance, one of the sponsors here. He has had talks, and this year he's not here, sadly, but hi, Vinny. And I have a small demo here. So I have this Python HTTP server open, but I could open the HTML directory. I can open this web page here, and this does nothing right now because I don't have a server. Let's start a server then. Okay, I'm starting a simple server here. Notice the console behind. I just need to refresh it's reconnected. I can send messages to the server, and the server just echoes them right back. And you see the server receives the messages and sends them right back to the browser. This server particular, I'm going to make a short run through the code here. Oops, sorry, this is not the correct file. This is the one. Okay, so now can everyone see the code? Okay, we have our main function here. It's a pretty simple main function. We start a server, which is a class that I've written. And the class that I've written does this. It creates an asynchronous accept function, so it starts listening for connections, start listening whether someone wants to connect to this server. And when someone does connect, it calls the callback onAccept. And in onAccept, we create a new session, again, a class that I've written, and we start running the session. And when the session starts running, basically, it accepts, it attaches itself to the connection to the browser here with async accept. And when the accept is done, it starts reading, basically listening for communication from the client. When we receive a read, in this particular case, we receive it here. There's a text packet, again, a class that I've written. We call onReceive. And onReceive here basically logs the packet that we've received and sends it right back. Send puts it in a queue and calls the doWrite method. And doWrite basically is used to asynchronously empty the queue from the messages that are queued to the client. Most of this is my code, like the actual BoostB specific part of it is pretty small. Those are mainly the WebSocket members, async accept, async read, and stuff like this. It's pretty simple. Oops. Anyway, I'm not going to go into too much details. As I said, inspirational, not educational. Vinny has done a lot of talks on BoostB. There's lots of documentation around. It's great. But if for some reason you want to use something else, or you want to just explore the field of WebSocket libraries for C++, here's a small list. I mentioned BoostB. It's a fully capable WebSocket and HTTP server. So if you do want to implement NPM, you could do it with BoostB. It's a client too, so it could be used as a client, not necessarily a server. There's micro WebSockets, which is a pretty neat library. I like it a lot. I recommend it wholeheartedly too. Again, it's a WebSocket, an HTTP server and client. There's WebSocket++, which is great, but the good part about WebSocket++ compared to the others is that the transport is interchangeable. So, for example, BoostB uses ASIO sockets. Micro WebSocket have their own socket implementation, whereas WebSocket++ doesn't have any. You could use ASIO, you could use your own library, platform-specific stuff. So if you want WebSockets with something that's not readily available in terms of transport, you can definitely check out WebSocket++. There's the simple WebSocket server library. It's a WebSocket-only solution, but the author has also simple HTTP server library, so you can employ both. And if you want to create like a WebSocket server with a few lines of code, this should be your choice. It's like 3 lines of code and you're done. And of course, many more libraries exist, and practically every major C++ framework out there has a WebSocket solution because it's 2019. WebSockets are all the rage right now, aren't they? And so the short list of pros of HTTP server. So this is Windows, and I have a Windows subsystem for Linux. So I don't have an X Windows server on that Linux here. But what I could do, sorry about that, I forgot the name of the application. I could start a server here. Then I can open my browser and see I'm browsing the Linux file system right now, because on my virtual machine, it's Windows subsystem for Linux, it's not a virtual machine, but it could as well be. So on my virtual Linux machine, I have a WebSocket server, and then it opens a simple interactive file browser. I can click directories, I can go up, I can click others. This is basically the repository with the demos. It works, it's marvelous. I don't need a X Windows server anymore, making my virtual machines or my WSL installation much smaller and lighter. You could have multiple sessions. Like the demos that I have, they support multiple sessions. So I could go here and open the same application and see they're the same. So different tabs of my browser have opened the same application, and they do different things. Now, in my case, this is really simple because my server is stateless. The application server is absolutely stateless, and you don't need to do anything to support this. But if your application does support multiple sessions, that's something cool you could do. Also, you don't have to use localhost. Now, I did use localhost, but you could create a server on your local network, or you could create an actual internet web server and create web applications with C++. It's easy now. And there are some cons of using a local HTTP server, and the main pro is also the main con. The client is a browser, and by that I mean this. Remember MVC, where the application is the model, the view is the user interface, and the controller is the communication, where this time when you have a server and a browser, where's the communication? It's in the ether in a way. It doesn't exist. So the controller code actually needs to be situated in the other ends of the diagram. So we have some controller code written in C++ in our application and some controller code written in JavaScript in the browser, which is not that pleasant, to be honest. Now you could compile, as I said, you could compile C++ to asm.js or WebAssembly and kind of make it work. It's possible, definitely. But as we'll see later, there are some kind of problems with that too. But it's a viable solution, definitely. Also, we don't have a single application. If we're talking about desktop applications, what the instructions for launching your application would be something like, okay, start this HTTP server, for example, start Nginx or Node or Python simple HTTP server, then start this WebSocket server, then open the browser to this URL. Not very pleasant now, is it? For advanced users, of course, they don't care, but if you're making like a regular desktop application, it might be like not really cool. Also, how do I stop the application? Well, you have to kill the process, or press Control-C where the server is running, something like this. Yeah, not nice. And also, there's lots of load on the network interface. Every single piece of communication that goes between the application and the user interface is through HTTP. So through the network transport. Now, I'm maybe exaggerating with this problem. This is not such a big problem on localhost. Localhost is pretty fast. HTTP is not that fast, but localhost takes care of it pretty good. So if we're talking about gigabytes of data, maybe you don't want to copy them, but anything smaller than that probably wouldn't be even noticeable. It depends, of course it depends, but there's something to be considered, certainly. And this kind of segues us into approach number 2, which is embedding a browser. This basically means to use the browser as a library. Why not have a function like open browser window to this URL? And for many platforms, this exists, and it's called WebView. I'm familiar and have some experience with the WebView on Android and on iOS, and they're pretty neat. They're great WebViews. But what can we do for C++? And before I continue with what we can do for C++, I'm going to do the browser architecture in a single slide. Browsers have tabs, modern browsers have tabs, and in those tabs you can have the pages, and in those pages you can have iframes. Well, iframe is basically a way to open a web page within another web page. And these things pose some security issues. For example, if I have Facebook open in one of my tabs, and I open hackety hack on my other tab, and the hacker has written some code that kind of through some fancy magic, buffer overflows and everything, gets the chance to read my Facebook memory, get my Facebook password, pictures, communication, everything. This is not nice. Another thing that hackety hack could potentially contain some code that opens some files from my file system, crypts them, then asks me for Bitcoin. It's again something unpleasant. That's why modern browsers have separate processes for everything. So those are the renderer processes. You have a browser process, which runs the GUI, the user input. And for every tab and for every iframe, you have a separate render process which deals with it. It's like a separate executable. So they don't even share the same address space. So there is no way through buffer overflows or anything to access the memory of another page. And also, these processes are sandboxed. This means that certain operating system APIs are forbidden for them. You cannot just open, fopen something from the render process. It's not allowed. So that's how browsers solve security, basically. And there is no way to communicate between those processes. There's literally no way. There are some, roundabouts, like cookies or something, but you have to support the same source. And so it doesn't basically work. And we can put the browser architecture in the language of our diagram and have the browser process and the multiple render processes for every tab and iframe, and they communicate with inter-process messages. And some of you may be familiar with my work, but I do like acronyms. So I've devised a new acronym for this talk, and this is the BRIB. The BRIB is basically the things that you need to know before embedding a browser. You need to know how to do with the browser before embedding it. And this is basically writing code for the browser process, writing code for the renderer process, inter-process communication, and the binding between JavaScript and C++ because the browser runs JavaScript and our application is presumably C++. If you know how to do this with your browser, then you can safely embed it. And in this case, things become exactly the same as the HTTP server and real browser scenario. You have your browser process or HTTP server. You have your render process or a browser, and they communicate through inter-process messages or XHR and WebSockets. Literally the same thing. So what can we do to embed browsers in C++? Now, there's QWebView. It wraps the native browser of the operating system, and it's pretty bare bones. Yeah, it doesn't support the brib, so we're not going to consider it. It can only open a web page, and that's basically it. There's this thing out from Qt 2, the Qt's web engine, and Qt's web engine wraps Chromium, and it's pretty good. There's Ceph, the Chromium embedded framework, which wraps Chromium 2. It's a C++ library, which wraps Chromium. Of course, there's Electron. You've probably anyone heard of Electron here? Yeah, of course, yeah, Electron is all the way. There's WebKit, and from all of these, actually, like, not all of these, but if we consider, like, browser engines, which are Chromium, WebKit, Gecko, whatever, WebKit is probably the user-friendliest to embed on your own. So you don't need fancy wrappers or anything. It has a pretty good interface, like a pretty good API for embedding. But the thing is that WebKit is GPL. So if you're willing to live with GPL, you can try WebKit. It's awesome. There's also a Qt wrapper of WebKit, Qt WebKit, but to my knowledge, it's very outdated, so probably don't use it. And there's Gecko. Gecko is the engine. WebKit is behind Safari. Most of you probably know. And Gecko is behind Firefox. That's the browser engine of Firefox. And I don't know much about Gecko. To my knowledge, all applications which actually embed Gecko are Mozilla applications. For example, Thunderbird. I don't know of any, and I might be wrong, but I don't know of any applications which actually use Gecko, so I'm like, I don't know. And one thing should be mentioned also here, and there's the proposal 1108 for the C++ standard, that's ToWebView. It's pretty bare bones. So far as it is, it's like QWebView. You can basically open a web page and that's it. But perhaps we can gather our forces and try to make it better. Who knows? And it's in the too early stages of development anyway. Probably won't be there for C++ 23. Could be for C++ 26, who knows? And you've seen that Chromium is pretty popular, and I'm going to focus more on Chromium. And if I'm focusing on Chromium, I cannot like omit Electron. Electron is everywhere these days. Electron powers Visual Studio Code. Most of us probably have, at least for a while, used Visual Studio Code. Chromium also powers Slack and many other applications. I'm sorry, like Electron also powers Slack and many other applications. And Electron, it's not a C++ library. It's basically this WebView thing, but for JavaScript. What Node.js is for the terminal, Electron is for the desktop. It's exactly the same as Node.js. It has the same OS APIs. It has the same native modules. If you create a native module for Node.js, you can just recompile the exact same code with linking it against Electron, and it will work. Everything, so it does support the brib, of course. It's a fully fledged browser wrapper, but it's in JavaScript. It's a browser wrapper for JavaScript. And it's basically a JavaScript programmer's dream come true and not a C++ programmer's one. It could, though, it could still work for you. Like Node.js and having a Node module could have worked before. Electron could work for you now. Perhaps this is what you want. And in this case, your application might look something like this. You have the Electron backend, the Electron frontend, like browser process, render process, and you can create C++ Electron modules for the browser process and the render process and have your code there and have all the communication passed through JavaScript and use Electron as a proxy, basically. There is no way for your different C++ worlds to communicate with each other than through JavaScript. Well, there's hacky ways, of course. You could write to a file and read from the same file. Sure, it's possible. But anyway, that's what I'm going to say for Electron. Check it out if you want. It's pretty neat. It's very popular, so there's lots of documentation and tutorials and everything around. Qt's web engine and Ceph. They are pretty good Chromium wrappers. They allow you to do basically everything Chromium can do. And thus, they have almost the exact same features. And the main difference, I'd say, between those is the license. I don't understand Qt's license. Like, you could do something free if it's open source and free, but then you have to pay insert. I don't understand it. And I'm not strictly against Qt, but I don't like using it, at least for my stuff. Most of you probably do use Qt, and Qt is a pretty decent choice. But I have some good words for Ceph too. Now, Ceph is somewhat strange in that it wraps the C++ code of Chromium in a C interface, and then provides a C++ wrapper of that C interface. But thanks to that C interface, there are actually lots and lots of Ceph-powered wrappers of Chromium. There's wrappers of Chromium for Java, for .NET, for Go, Python, many other languages based on that exact C API of Ceph. So that's pretty neat. So that's cool. You might not use them, but at least it's cool, right? In fact, Electron used to be Ceph. Electron used to be the JavaScript wrapper of Chromium powered by Ceph. Now it eventually outgrew Ceph, so currently it wraps pure Chromium. It does not use Ceph, but it started as a Ceph wrapper. And here's a small demo. My demos use Ceph because, as I said, I don't understand the Qt license. So I forgot the names of my executables. OK. Here's the same echo demo. I can call send. I can get the response. But this time, I don't have a server because everything is a single application. This is basically Chromium, HTML, wrapped within the same application. This is almost entirely the exact same code as I used for the previous echo demo. But instead of WebSocket, I communicate with Ceph. So let's go really quickly through the code. Oops. Let's start from the end. OK, this is our main function. And Ceph works like this. It starts the executable, and then starts the exact same executable for every other process. So when you click on the executable, it obviously starts, and that's the browser process. And then internally, it will start itself multiple times for every renderer process. So this is what we do here. If the application type is a renderer, on Linux, this is called the zygote. So we create a render application and then call Ceph execute process. And Ceph execute process will stop here and return some positive value or 0 if this is a browser process, and we should stop the execution here because this is our, if it's a render process, I'm sorry. And because we're writing code for the browser process, we go along to the end. We create a browser and run the message loop. That's in I know, very short run through the code. OK, so what's important here is we also created this client thing. The client is basically the code we write for the browser process. It can it can support multiple interfaces. And for now, I'm supporting, for example, the request handler. So when the browser process requests a web page, I'm not going to allow it to go to the internet, but instead, I'm going to load some files from the file system and send them to the browser. So this is how I manage the resources that my browser is using. This is powered by the request handler, the resource request handler. The most important thing here, though, is on process message received. So I could receive a process message from the renderer process, which is on echo in my case, in which case I log it, and I create a response with the exact same text, and I send it back. This is the response. I set the text that I just got as an argument, and I send it right back. So this is the render process. I receive some message, I send it right back. What about the browser process? I'm sorry, this is the browser process. What about the renderer process? I probably messed it up like 1,000,000 times already. The browser is an application, right? The application listens for messages and sends them right back. The renderer, which is the front end, doesn't know anything about this crazy logic of returning the exact same thing again. So the renderer, what does it do? The renderer, well, first of all, it can receive a response from the browser process and send it to JavaScript. And here I'm using a small little library called JSBind. Now, Ceph does have a C++ to JavaScript binding interface, but I find this library pretty easy to use, mainly because I wrote it. Anyway, JSBind, basically, what do I do with JSBind? When I create my renderer process, I initialize it, then I use it to communicate between C++ and JavaScript. With it, I've created several small functions. Oh my God, I'm lost in my own code. OK, JSBind bindings, I'm here. I expose the function echo, which the browser, the HTML calls. And I also expose this function, which is used by the HTML5 code to set the callback that I'm going to use to respond with messages. This is basically the gist of it. I also can run the exact same file system browser. Oh, you notice here? Those are the logs of the messages that I sent. So, oops, I'm not writing anything. And in this case, is the absolutely exact same code. This is the exact same HTML that I used before, but this time I'm browsing my Windows file system in a single application. If you notice here, it was app type. Previous time it was HTML, WebSocket, and this time app type is Ceph. Anyway, it works. It can be done very easily. And a few words about JSBind. You can find here it's open source, MIT licensed, and it's basically a library which allows you to bind JavaScript to C++, supporting many different backends. So in this case, it supports the Ceph particular way of binding C++ and JavaScript, but it also supports pure V8. It supports like WebKit JavaScript core. It supports Node.js. So if you have your C++ application written with JSBind, and you decide to switch from Ceph to WebKit or to a Node module, you could presumably keep 100% of your existing C++ code. Because the binding, the JavaScript to C++ binding is exactly the same C++ code. Anyway, so basically this is how the architecture looks in this case. We have the browser process, we have the render process, we have inter-process messages, and we have some JSBind or other, binding between C++ and JavaScript, and this is where the controller part of our MVC lies. And there are more variants of when embedding a browser, of course. A cool thing about it is you could embed the browser in existing GUI that you have, existing platform-specific GUI that you've created. And in this regard, Qt's web engine is the clear winner because it's Qt. So it works with everything that you created with Qt. Whereas Ceph doesn't provide anything for you to use like platform-specific GUI. It provides like a handle to the actual browser window, but that's it. You're responsible to creating your own, usages of that handle. Also, what if you want custom rendering? Say you want, a game, or something that basically you want the rendering not to be in the browser, but in C++. Now, it could be in the browser. Modern browsers support WebGL, and WebGL is pretty powerful. But what if, for example, WebGL is not enough for you, or you want DirectX, or you want some other specific rendering thing you have? So you could do this. You could render off-screen. You could collect the pixels from the off-screen target that you've created, and you can send them to the browser. And this works. This is something that we actually did at a company I used to work for before. We had a game editor with a HTML5 GUI, and it ran the engine inside, but the engine had its own OpenGL rendering. So we render to an off-screen target, GL read pixels, send the pixels to the browser, and it then presents them with its own layout, HTML layouting engine in the appropriate place, in the appropriate ways. You could get the browser screen too. Now, Ceph, for example, and Qt's web engine, they both support a way to do the opposite thing. Not read your own rendering data and send it to the browser, but read the browser's rendering data and use it yourself. And I have a small demo that does that too. What I have here is an OpenGL application written in C++. It can rotate a cube, oops, and I have browser GUI over it. I can click stuff here, and I have like counters here that count the number of revolutions. Let's speed it up. Okay, so I have more revolutions. And this is C++ rendering with HTML GUI. And I can also go here, go back, and open this same web page, which is this one. And of course, it has no rendering because C++ is not running behind it. This is just the HTML page that I've created. OK. I'm running out of time here. Anyway, I have the demo for this. But again, as I said before, for the browser server scenario, there was lots of load on the networking, like on the local host networking, but still, it was copying data around. And in this case, when you have the browser process and the render process, and they don't share address space or anything, they're still copying of memory around. And you, as I said before, that's something that you might not want. It could be OK, though. Small amounts of memory are pretty fine. So you could write your code entirely in the render process. You have to turn off sandboxing for you to be able to open files, start threads, and do other stuff that the operating system allows you to do. But you could actually move your entire application in the render process. This demo I'll skip. It's pretty basic. It basically shows this. And when you're working the render process, you could also share memory. JavaScript supports array buffers. And you could basically have a buffer of C++ memory and just give it to JavaScript to work with. And opposite is also true. JavaScript can allocate some memory, and you can use it in C++. It's easy when you work in the render process. And in this case, in the language of our diagram, this would look something like this. You have the browser process, which is grayed out because it's irrelevant. You have the render process, where the user interface and the application run in the same application, but it's still separate. They're still in separate languages. The user interface is JavaScript, your application is C++, and they communicate synchronously by sharing memory in the same process. This could work. So what's good about this? You write your controller code in C++, you got that. You could combine the browser UI with the existing GUI that you've written for your platform, and you can work entirely in the render process. What's bad about this? Well, it seems that the fancy workflow is lost, isn't it? The npm start thing, well, now we have the browser process entirely in C++. But the thing is that that's not true. We are embedding a browser. And as I started, I'm forbidding the browser from opening the network. The browser could not do that. The browser could still open localhost something, and get the HTML5 content from there, from presumably a Node.js server. And it could still run, instead of WebSockets, it could run the inter-process communication with our C++ backend. So it is not lost. It can totally work. And also, that's not something that you need to release. You might use it in development only, and when you're ready to release, you disable this feature and you serve static HTML content to the browser from your C++ end, and there are no multiple applications running. And do I have time? OK, let's say I do. I'm running the 3D demo again. And in my browser here, my actual browser, I'm going to open another local server. So this is basically remote DevTools. And remote DevTools works with both Ceph and Qt's web GUI. I don't have the C++ rendering here because, of course, it's in my C++ part. The remote GUI has no way of knowing about it. But still, everything works. I can, oh my God, why is it black on black? Oops. Well, this didn't happen. Everything works. Imagine the demo was perfect. Thank you, thanks. My Ceph application crashed for some reason, not sure yet why, but it works. Like I did it like a million times before this talk, and now, of course, now it will crash. Anyway, I won't do it again because I don't have that much time. Also, if you don't want to do that, of course, mocking and front-end developers will tell you all about mocking. For example, my file system browser thing supports mocking. So if I open it in my browser here, you see application type. Oh, I still have the server running. That's why it works. Oops, not you. Ooh, I don't have the server running? Oh, that's the Linux server. OK. OK, so I disconnect and application type is mock. And in this case, I just have a list of files and directories directly hard-coded in JavaScript for me to test my application without any servers or any applications whatsoever. So mocking basically works, and your front-end developers will know all about it. Now, debugging multiple processes is much harder than debugging a single process. And anyone have experience debugging multiple processes? Well, luckily, Visual Studio helps a lot, and there are other tools, I'm sure, though I'm not familiar with all of these, but Visual Studio currently is pretty powerful in multi-process debugging. And also, if everything's in the render process, you don't need to debug the browser process. You only need to debug the render process, right? Also, there's this thing called single process mode. Now, WebKit and Chromium and Firefox support it. I'm not sure about how it works when you're embedding WebKit, but if you're embedding Chromium, you can basically run in single process mode and have your renderer processes actually be threads and not actual processes. Now, this is pretty dangerous. Don't do it for browsers, but if you're serving your own content, you can do it. The thing is, though, Qt's Web Engine doesn't support it at all. Single process mode is impossible with Qt's Web Engine. And it is possible with Ceph, but they officially don't support it. So if you absolutely positively need single process mode, you cannot use, to release in single process mode, you cannot use Ceph and Qt's Web Engine. Though, if you only need for debugging purposes, like multi-process debugging is hard, you want to debug a single process with threads, in debug mode, it's a pretty viable solution with Ceph too. Just don't release with it. Anyway, but what if we want to go faster? And I have to go faster because I'm out of time. We want to support custom rendering. We want to support synchronous communication between the application and the web page. And we also want to share video memory. And this is approach 3, and I'm going to be really brief with it because it's typically game dev territory, and it's really niche. Those are custom HTML renderers. And basically, we're taking the renderer process out of the browser and using this alone as a library. So such libraries would have similar characteristics. They'll be similar to many existing GUI libraries. They'll be graphics only, so without the browser, we don't have the input, we don't have the networking, we probably don't have sound too, because it's rendering only. And they will allow you in some way to bring your own renderer. So they'll produce some kind of primitives that you will need to present on the screen on your own. And there are at least some DOM and API changes. For example, since there's no networking, obviously there's no WebSocket in those custom applications, custom libraries, custom HTML renderers. And they have like their own custom ways of dealing with their application. This is not valid HTML, but it's valid for certain libraries. This idea over there could be like a texture from your game that could be displayed in the browser UI. And almost complete solutions exist, like almost entirely the full HTML5 support is in there with certain exclusions. But none of them are free and open source. There's Ultralight, which is free for free software, so you can play with it. And basically stripped down WebKit. The author took WebKit, removed everything that wasn't renderer from it, and just packaged it up as a library. So it basically works. There's this thing, Coherent Game Face, which is a totally custom HTML5 renderer made from scratch. It's not free. You have to write to the company if you want like a evaluation copy or something. It's the complete custom implementation, but we do know some things about their implementation because last year, one of the authors talked at CppCon about their implementation of the custom HTML5 renderer. Those are some partial solutions. Note QML is also here. QML is basically a partial HTML5 thing. It doesn't support the HTML5 DOM. It has its own custom DOM. And so your typical HTML5 developer wouldn't be just able to sit and write some cute, but for example, it could run React because React doesn't depend on the DOM. And approach 4, oh my God, approach 4. It's approach 3.5. It's something that I need to say because we had a talk about it, so it's probably this will be the first question. We could actually compile C++ to WebAssembly or asm.js. We could run it in the browser, have the entire application in the browser. It's possible. It might be something you want. But this is not part of my talk because you will have to conform to the browser platform. So I won't go into detail. Browser platform has no threads, at least not in the way we C++ programmers are used to having. It has no file system access, at least not in the way we are used to having. And many other platform-specific stuff is associated with the browser platform. But it is possible, it's a viable solution. And if you want to talk about this some more, I have like an impromptu open content session tonight, late, 8:30 p.m. in Crest 3. If you want to run the demos, for example, talk about it some more, I'll help you run the demos on your own machines. You can join me there. And with that, I thank you.
Just a couple of things. First off, I was surprised you didn't mention anything about cross-platform. Does this make generating cross-platform apps easier, but you don't need to write multiple UIs? Yep. And then the other question is, anytime we hear Electron, it could be Slack, Teams, whatever, everyone says, oh, it just uses tons of memory. Is that the case here? Is it the Electron part, or is it the Chromium part?
Well, it's a combination too, because Electron actually starts a JavaScript engine for the browser process to unload a lot of stuff, which Node.js specific stuff, like platform specific stuff in the browser process, which your regular browser doesn't do. It doesn't start JavaScript in the browser process. But also, Chromium plain old uses a lot of memory. It's blazingly fast. It uses power, very small amount of power, but it just uses a lot of memory. So the majority of that memory is, I'd say, Chromium. Hi.
Hi, I'm Hal. I wrote the WebView proposal for the
Oh,
committee.
right.
So I'm kind of curious what you think about what else we would want to add to it. And
Well,
also I'll mention I'll probably stop by at 8:30 in case you want to.
Sure, yeah, that would be the best place for us to talk about it some more. I'm not sure that there's a lot of stuff, and I'm not sure that whether a question here is the appropriate way. But yeah, sure, like multi-process support, JavaScript support, those are the most important things. The brib.
Yeah,
If you cover the brib, then you should be
cool.
all
I'll stop
set.
by at 8:30.
Sure, thanks.
So the inter-process communication in the examples you were giving were still over HTTP, right? So these are separate processes still?
Yes, but it uses platform specific. Like it uses what Chromium uses, and Chromium uses what's best for your platform. Yeah, it could be pipes, it could be like Windows has inter-process communication with it. Windows even has shared memory, though this is not what Chromium does in Windows, but it's a platform-specific solution.
But in your experience, do you have any issues with firewalls, for example, does the user have to enable?
With Ceph, with an embedded browser?
Yeah.
No, first time I hear that a firewall could have something to do with it. Chromium works like this. If a firewall could mess up my Ceph application, it would mess up Chromium too, right? Oh, okay, let's go to Herb's talk then.